aniline has 6 carbons with 5 hydrogens and 1 nitrogen with 2 hydrogens, and reacts with the oxygen to produce carbon dioxide, water, and nitrogens. So now I'm going to assign a variable for each molecule. We start with the reactant side. We give the molecule of aniline variable A, the molecule of oxygen, the oxygen, the variable of B, the molecule of carbon dioxide, the variable of C, the molecule of water, the variable D, and for the nitrogens, E. So now I'm going to assign an equation for each element. We start always with the reactant side. So we have for the aniline, we have for the carbons, we have 6 carbons in the molecule of aniline. So this gives us a 6A. Okay, so with the subscript is now the coefficients of the temporary variable. Okay. So now we have 6A, so there are no more carbons here. So now we look at the product side, we have just 1 carbon on the carbon dioxide. So this gives us 1C equals 1C. Now we look at the next element, which is hydrogen. So in the molecule of aniline, we have 5 plus 7, plus 2, 7, sorry. 5 plus 2 hydrogens on the same molecule. We can add them up together, so this gives us 7 hydrogen, 7A. Okay, 7A. So no more hydrogens here. So now we look to the product side. So we have 2 hydrogens here, so this will give us 2D. Now we look at the nitrogens. The next element is nitrogen. So nitrogen, this gives us 1A equals 2E. Now the oxygens. On the right hand side we still have 2 oxygens, the oxidizer, the most important part for the combustion, so the oxygen. Okay, so this is 2B, and on the product side we have 2 oxygens for the carbon dioxide, so this gives us 2C plus 1 oxygen in the molecule of water. This gives us 1D plus 1D, and that's it. We have the variables, we have our system of linear equations, and now we have to find the degrees of freedom. So to find the degrees of freedom, remember you have to count how many variables we have. We have 1, 2, 3, 4, 5. So we have 5 variables. And how many equations? First we look at the equations, we number the equations, but before that make sure there is not any redundancy in the equation, that we can simplify and all that, because that will be less equations to count. Okay, and then more degrees of freedom. So but in this case we just have 1, 2, 3, 4. There is no any redundancy here, no. So we are and anyway we can simplify something, no. Okay, so I just want to number the equations 1, 2, 3, 4. Yeah, it is better to number the equations, because then you know what you are doing and where are you, so it makes things easier. Okay, so let's get the degrees of freedom. 5 minus 4 equals 1 degree of freedom. So that's it. So we're going to assign the value of 1, which is the minimum whole integral we can give to the coefficients. So because we want the lowest ratio of molecular for the balance. So let's give the value to the molecule that has the most complex molecule. Okay, we give this value to the variable that has the most complex molecule, which is A in the aniline. So A equals 1. So now we change B, C, D, E. So now we leave A, and now we have to solve for B, C, D, and E. So now we know that A equals 1. So now we are going to plug the values there, and we are going to solve for C. We are going to do equation 1. So 6 times 1 equals C. I'm not going to write down 1 all the time when it's just 1, because it's obvious if we don't write the number, the coefficient 1, it's just because we know it's 1. Okay, so 6 times 1 is 6 equals C. If 6 equals C, then C equals 6. Okay, so 6 equals 6, and this is the value of C, the number 6. So now we are going to solve for, let's solve for equation number 2. So 7 times 1 equals 2D. So we solve for D. So D equals 7 over 2. Don't panic about the denominator. We are not going to divide 7 by 2. No, we don't use decimals for the stoichiometry coefficients. We are going to get rid of the denominator at the very end. So at the moment, just leave it as it is. Don't worry for this. Just stay until the end, so you will see how we get rid of the denominators. So 7 over 2. 7 over 2. So now we have equation number 3, which is 1a. Plugging the value of a, 1, and e. We solve for e. So e to e. So isolate e. So e equals 1 over 2. So the same. So don't panic if you get fractions, because we are going to get rid of them at the very end. So I'm just going to write down the variable e at the bottom where it has more space. Yeah, that's it. So now we are going to do b, the last one. Okay, so equation number 4, we have to solve for b. So 2b equals the value of c, which is 6, plus 1d, which is 7 over 2, and that's it. So now we have to combine items, they are combined. Okay, so that's it. So let's solve this fraction with the whole number. So this is 2b equals 12 plus 7 over 2. So the shortcut, I always just multiply 12 by the 2, because it's going to give you the same result. Okay, so yes, the whole number by the denominator. So this is going to be 2b equals 24 plus 7 over 2. So this is 2b equals 31 over 2. So now you isolate b. So b equals 31 over 2 divided by 2. So you just cross multiply. You just cross the multiplication. So b equals 31 over 4. So here we have another denominator, but don't worry, we are going to get rid of the denominator in a minute. So this is 31 over 4. Okay, so now we are going to write down, to keep things tidy and steady. So we are going to write down again the variables here, because we are going to get rid of the denominators. To get rid of the denominators, we are going to look for the highest denominator, which is 4. First, we are going to multiply everything by 4 to get rid of the denominator. Okay, so 1 times 4 equals 4. Now b, because it has the denominator itself, it doesn't count. So b equals 31. So now the next one is 6. 6 times 4 equals 24. So now we count for the next one is 7 2. Okay, so we have to multiply 7 over 2 times 4. So this gives us 28 over 2. If you divide 28 by 2, it gives 14. Okay, you always, every time you have a fraction, you have to simplify to the lowest term. Okay, and it has to be a whole number. In this case, it's 14, so this is correct to do so. Okay, so now we do E. So E is 1 over 2 times 4. This gives us 4 over 2, and this is 2. Okay, you divide, it gives us 2. So now if you want, you can write down, we can just highlight the new coefficients, because there are so many information, a lot of data here. So 1, 2, 3, 4, 5. So these are the new coefficients. Now I'm going to write down balance. Okay, balance, because we know that our equation is balanced. And if you want, still you can write down here the coefficients so you can see what we did, but I'm not going to delete the variables. Okay, so if you want to study this, it makes easier for you to see. So this is 31, this is 24, this is 14, and this is 2. Okay, but still I'm going to write down the whole equation. I'm going to write down with 4, with red, the number 4, the coefficients for the equation, so it makes easier to see things, you know. Yes. Yeah, when I start studying stoichiometry and using the algebraic method, it takes me ages just to put my head around everything, and just the focus, it was not there. So it takes time, you know, to focus. But once you get into it, it's very, very easy, very easy. I just can't believe how easy it is. So let's I like this method because it's very accurate, it's very exact, it gives you the lowest ratio of yeah, always the lowest ratio of molecules when you want to balance the equation. So I hope you find this interesting. Yeah, because I was very tired of using the guessing method, the inspection method. Yes, especially when you have to rush, you don't want to double check all the time, and you want everything exact. You want to be accurate. So I hope I got enough room for this. Oh my god, no, I don't want to have enough room. I have to write down in a small letter. Sorry about this. So I just try to figure out next time what can I do to make sure all the questions fit into the same area. So now we have here the last bit. Oh please, come on please. So we have this one and 2 for nitrogens. Okay, sorry guys, I hope this makes sense. Sorry about the last millimeter of the screen. So this is the equation balance. So 4 molecules of aniline react with 31 molecules of the oxygen to produce just 24 molecules of carbon dioxide, 14 molecules of water, and 2 molecules of nitrogen. So that's it. So I hope you enjoyed this video. If you find it useful, please thumbs up, and I hope to see you in the next one. Bye.